Picture this. It's 1976, and a Dodge Power Wagon is stuck axle-deep in West Texas mud, while a beat-up ranch truck with mismatched wheels drives right past it, like the mud isn't even there. The Power Wagon driver, who paid $8,000 for factory four-wheel drive, watches in disbelief as this Franken truck disappears into the distance. Under that ranch truck's hood sits a four-wheel drive system built from windmill parts, tractor gears, and pure Texas stubbornness that worked better than anything Dodge engineers had designed, and it cost $300 in scrap metal. The four-wheel drive problem. Why four-wheel drive in 1976 was such a disaster. Detroit had been building 4x4s since World War II, but they treated it like a specialty product for rich weekend warriors, not a tool for people who actually worked. The systems were complex, unreliable, and criminally expensive. Take the 1976 Dodge Power Wagon. The four-wheel drive system added $2,800 to the base price. That's over $15,000 in today's money. For that premium, you got a transfer case that weighed 180 pounds, required constant maintenance, and had a nasty habit of locking up at exactly the wrong moment. The front axle disconnect system used vacuum lines that cracked in cold weather, leaving you in two-wheel drive when you needed four-wheel drive most. The engagement mechanism was equally terrible. You had to be moving at exactly the right speed, usually between 5 and 15 miles per hour, or it wouldn't engage. Too slow and the gears wouldn't mesh. Too fast and you'd strip teeth. God help you if you tried to engage it while turning or on an incline. The whole system was designed by engineers who apparently never left the parking lot. Fuel economy was pathetic. The Power Wagon's four-wheel drive system created so much parasitic drag that even when disengaged, you lost 3 miles per gallon compared to a two-wheel drive truck. Engaged, it dropped to about 8 miles per gallon. In the middle of the oil crisis, this was like setting money on fire. Reliability was a joke. The new process transfer case used in most Dodge trucks had a failure rate that would make a Lucas electrical system look reliable. The shift fork would break, the chain would stretch, the bearings would fail. Dodge dealerships made more money fixing four-wheel drive systems than they did selling trucks. But here's the real problem. The system was binary. You were either in two-wheel drive or four-wheel drive. There was no in-between, no modulation, no intelligence. Hit a patch of ice while in two-wheel drive, and you were spinning helplessly. Switch to four-wheel drive on dry pavement, and you'd bind up the drivetrain so badly you could snap an axle shaft. For weekend warriors driving to ski resorts, this was annoying. For ranchers who needed to check fence lines in mud, pull stuck cattle out of creek beds, and navigate terrain that would make a mountain goat nervous, it was completely unacceptable. You needed four-wheel drive that worked automatically, engaged smoothly, and didn't require an engineering degree to operate. The cost of failure wasn't just inconvenience. In the ranching world, getting stuck could mean missing a sick animal, losing a calf in a storm, or spending half a day winching yourself out of a creek bed when you had 1,000 other things to do. Detroit's engineers didn't understand this. To them, four-wheel drive was a luxury feature for guys who wanted to feel rugged on the way to their ski cabin. To working ranchers, it was the difference between getting the job done and going broke. Meet Clayton Marsh. Enter Clayton Marsh. Born in 1938 on a ranch outside Amarillo, Texas, Marsh grew up in a world governed by distance, necessity, and stubborn self-reliance. If something broke, you fixed it yourself, because the nearest mechanic was 60 miles away and likely didn't have the right parts, even if you made the trip. His formal education ended after 10th grade, but what he lacked in credentials he made up for with a lifetime of improvisation. Marsh developed an intuitive understanding of machinery, a kind of hands-on doctorate earned by necessity rather than study, grounded in making broken things work again with whatever materials were available. By 1976, Marsh was running a 3,000-acre cattle operation alongside his two sons. The land was unforgiving, the weather unpredictable, and the work constant. Trucks were not conveniences, they were lifelines. Yet over the previous 10 years, he had gone through 5 of them, and every single one had become hopelessly stuck, at least once in situations that should have been routine. Muddy fields, shallow creek beds, gentle inclines, conditions that should have posed no challenge routinely turned into hours-long ordeals involving tractors, chains, and a lot of frustration. Marsh tried the obvious solutions first. Factory four-wheel drive trucks promised capability, but in practice they proved delicate and expensive. Components failed regularly, repairs drained money and time, and downtime during critical work periods was unacceptable. He experimented with chaining all four wheels together using heavy tractor chains, a crude but effective solution that provided traction when nothing else would. Unfortunately, it also destroyed tires, punished axles, and made the truck handle like a shopping cart with a bad wheel. It worked, but it was not a solution anyone could live with. What Marsh needed was deceptively simple. He wanted four-wheel drive that engaged automatically when traction was lost and disengaged, just as automatically when it was no longer needed. It had to require no driver input, because ranch work demanded attention elsewhere. It had to be reliable, inexpensive, and repairable using parts he could afford and understand. Most importantly, it had to survive the realities of daily ranch use. When Marsh described this vision to people in the automotive world, the response was dismissive. Detroit insisted that such a system was impossible with 1970s technology. Marsh did not argue. He simply went back to work. The breakthrough came not in a lab or a design office, but out in the pasture. Scattered across Marsh's land were windmills, old mechanical structures that had pumped water for decades, with minimal maintenance. They responded automatically to changing wind conditions, engaging when needed, and easing off when they weren't, all without electronics, sensors, or human intervention. Marsh saw in them a principle Detroit had overlooked. Mechanical systems could think, in a way, if designed correctly. This insight resonated because Marsh was not a hobbyist or a dreamer. He was a working rancher who had spent decades maintaining every piece of equipment he owned because paying someone else was rarely an option. He had rebuilt tractor transmissions on dirt floors, welded broken plows back into service, and fabricated replacement parts for machines that manufacturers had stopped supporting 30 years earlier. When you are 40 miles from the nearest parts store and responsible for hundreds of animals, improvisation becomes a survival skill. Marsh's approach to problem-solving was purely practical. He had no interest in elegant theory or academic perfection. He cared about what worked, what lasted, and what could be fixed with basic tools in a barn lit by a single bulb. Complexity was a liability. Simplicity was strength. That mindset shaped everything he touched, and it would prove essential as he began translating the quiet wisdom of windmills into a mechanical solution Detroit had declared impossible: the windmill revelation. Here's where it gets interesting. West Texas ranches in the 1970s were dotted with windmills, but not the sleek, modern turbines that generate electricity today. These were old-school water-pumping windmills, many of them installed in the 1800s, still faithfully doing their job decades later. They didn't rely on electronics or complex controls. Instead, they used an elegantly simple mechanical system to convert rotating motion into the up and down movement needed to pump water from deep underground. At the heart of that system was something far more important than the pump itself: the governor. A windmill has a problem that seems trivial until you think about it. It needs to pump water whether the wind is barely stirring or howling across the plains. Turn too slowly, and you don't move enough water to keep cattle alive. Turn too fast, and you snap the pump rod, destroying the entire system. The solution was a centrifugal governor, a purely mechanical device that automatically adjusted the angle of the blades based on rotational speed. When the wind picked up, centrifugal force pushed weighted arms outward, feathering the blades and slowing the rotation. When the wind died down, the weights fell inward. The blades caught more air, and the windmill sped back up. No sensors, no switches, no human involvement. Just physics doing the thinking. Clayton Marsh knew this system inside and out. Over the years, he had rebuilt probably 50 windmill governors, often with improvised parts and handmade fixes. He understood exactly how centrifugal force acted on weighted arms, how those arms moved linkages, and how small changes in geometry could control large amounts of mechanical power. To Marsh, the governor wasn't a curiosity or a relic. It was a proven solution to a real-world problem, refined by generations of engineers who understood failure was not an option. One day in early 1976, while replacing a worn governor on a windmill near his main barn, the connection clicked. As he watched the weighted arms swing outward and the blades subtly change their pitch, Marsh had an epiphany. What if the same principle could be used to solve his truck problem? What if centrifugal force could decide, automatically and mechanically, when four-wheel drive was needed? The idea was almost embarrassingly simple. Mount a windmill-style centrifugal governor to the truck's driveshaft. Under normal conditions, the rear wheels turn at a speed that matches the truck's forward motion. But when the rear wheels lose traction, they begin to spin faster than the vehicle is actually moving. That sudden increase in driveshaft speed is exactly what a governor is designed to detect. As the shaft spins faster, centrifugal force pushes the governor's weighted arms outward. Those arms engage a mechanical linkage, which in turn connects the front driveshaft to the transfer case output. Instantly, the front wheels come alive. Traction is restored. As soon as wheel speed normalizes, the weights retract, the linkage disengages, and the truck returns to two-wheel drive. No buttons, no levers, no electronics. Just automatic four-wheel drive built from parts available at any farm supply store. Most people would have laughed, dismissed the idea as impractical, and gone back to their daily routine. Marsh did the opposite. He spent the next 6 months methodically turning the concept into reality, testing, refining, breaking, and rebuilding until it worked the way he needed it to work. What made the windmill governor so appealing wasn't just its simplicity, it was its proven toughness. These devices ran for decades in brutal West Texas heat, freezing winters, abrasive dust storms, and near-total neglect. They were designed by engineers who knew no one would be checking tolerances or replacing worn parts on a schedule. If a governor failed, entire herds could die of thirst. That level of reliability was exactly what Marsh needed. For him, this wasn't clever engineering. It was survival-grade engineering. The technical solution. The technical execution was where Marsh's genius really showed. He started with a 1973 Dodge half-ton that had already given up its transmission. The truck was basically free, and Marsh figured if he destroyed it during development, no great loss. He pulled the entire drivetrain and started fabricating. The heart of the system was indeed a windmill governor, specifically a unit from an aeromotor 8-footer, the most common windmill in Texas. These governors were overbuilt cast iron assemblies designed to run for decades with minimal maintenance. Marsh mounted it to a bracket welded onto the truck's rear drive shaft, just behind the transmission output. The governor had two weighted arms that swung outward with centrifugal force. In a windmill, these arms pulled a linkage that adjusted blade pitch. In Marsh's system, they pulled a cable that engaged a dog clutch he'd fabricated from tractor parts. The dog clutch connected a modified front drive shaft to a power takeoff he'd mounted on the transfer case. Here's where it gets clever. Marsh didn't use the truck's existing transfer case for four-wheel drive. He left it permanently in two-wheel drive high range. Instead, he added a separate power takeoff from the transfer case output shaft that could drive the front axle independently. This meant the front axle only got power when the governor engaged it, but the rear axle was always driven normally. The front axle itself came from a wrecked power wagon. Marsh cut the housing down, narrowed it to fit his half-ton's track width, and installed it with custom-fabricated leaf spring mounts. The steering linkage required complete redesign, but Marsh had built enough farm equipment to figure it out. He used a crossover steering setup borrowed from Tractor Design, which actually improved the truck's turning radius compared to stock. The dog clutch was pure farm equipment technology. 2 plates with interlocking teeth, one splined to the PTO shaft, one floating on a bearing. When the governor cable pulled, the floating plate slid into engagement. Spring pressure from old windmill mainsprings kept it disengaged by default. The whole assembly weighed maybe 30 pounds and cost about $40 in raw materials. Calibrating the governor was trial and error. Too sensitive, and it would engage on every tiny wheel slip. Too insensitive, and you'd be buried before it kicked in. Marsh spent weeks adjusting the governor weights, spring tensions, and linkage ratios until the system engaged at exactly the right threshold. About 5% rear wheel slip would trigger engagement. Once engaged, it would stay engaged until wheel speed synchronized, then automatically disengage. The beauty of this system was its simplicity. No vacuum lines to crack, no electric motors to burn out, no complex hydraulics to leak, just weighted arms, cables, springs, and dog clutches. Parts that any farmer could understand, repair, and source locally. The entire system had maybe 20 moving parts, total compared to the hundreds in a factory four-wheel drive system. Marsh also added a manual override, a simple cable-operated lever mounted under the dash. Pull it, and you could manually engage the front axle regardless of what the governor wanted. Push it in, and the system went back to automatic mode. This meant you could pre-engage four-wheel drive before attempting something difficult, or force it to disengage if you needed two-wheel drive for some reason. The front differential was locked solid. No limited slip, no differential at all, just a spool welded in place. This meant when four-wheel drive engaged, both front wheels got equal power. It made the truck understeer like a freight train on pavement, but in mud or loose terrain, it was exactly what you wanted. Marsh figured if you were on pavement, you didn't need four-wheel drive anyway. The governor mechanism itself was a work of art in its simplicity. The weighted arms were balanced so precisely that they responded to drive shaft speed changes within milliseconds. The linkage geometry was designed so the engagement force increased progressively as the arm swung out, ensuring smooth clutch engagement even under load. Marsh had essentially created a purely mechanical traction control system decades before electronics made it mainstream. Building and testing this contraption was an adventure. Marsh's first test was in a muddy stock tank area that had swallowed more than one ranch vehicle over the years. He drove straight in, felt the rear wheels start spinning, heard the governor mechanism clank into engagement, and drove straight through without even slowing down. His son, watching from a safe distance, later said it was like watching physics get confused. The initial system had problems, of course. The dog clutch would sometimes jam if engagement happened while the truck was at full throttle. Marsh solved this by adding a ramp to the clutch teeth that forced them to engage gradually. The governor cable stretched under load, requiring periodic adjustment. He switched to aircraft control cable, problem solved. The front axle bearings wore out quickly because Marsh had initially used regular truck bearings not designed for constant engagement and disengagement. He swapped in heavy-duty tractor bearings from a John Deere, and they lasted indefinitely. The leaf springs on the front axle were too soft, causing the axle to hop under power. Stiffer springs from a 3/4 ton fixed that, but the real proof came in daily use. Marsh's ranch work involved crossing creek beds, muddy pastures, sandy soil, rocky terrain, basically every condition that makes four-wheel drive necessary. The automatic system worked flawlessly. Hit mud, feel a slight clunk as the front axle engaged, drive through, feel it disengage automatically on solid ground. No thinking, no shifting, no drama. Compared to his old Power Wagon, the differences were stark. The Power Wagon was faster on pavement and had more ground clearance, but in actual working conditions, Marsh's conversion ate it alive. The automatic engagement meant you never got stuck because you forgot to shift into four-wheel drive. The mechanical simplicity meant nothing broke. The lack of a heavy transfer case meant better fuel economy. Even in two-wheel drive mode, Marsh's truck got better mileage than the Power Wagon because there was no parasitic drag from a transfer case. The weight savings were substantial. The entire conversion added about 200 pounds to the truck versus the 500-plus pounds of a factory system. This meant better payload capacity, better handling, and less wear on the suspension. The truck actually handled better than it had stock because the front axle weight improved traction and steering feel. Cost was the real kicker. Marsh had about $300 into parts, most of that for the salvaged Power Wagon front axle. A factory four-wheel drive system would have cost $2,800 plus installation. He'd built something better for 1/10 the price using scrap metal and windmill parts. The testing phase revealed something interesting. The system was actually smarter than Marsh had anticipated. Because it engaged based on wheel speed differential rather than driver input, it would partially engage in situations where you needed just a bit of extra traction. Hit a slick spot on a hill, and you'd feel the front axle grab just enough to keep you moving. The mechanical nature of the governor meant it could modulate engagement in ways that binary factory systems couldn't. Why Dodge ignored this? So why didn't Dodge do this? The answer's the same as always. Corporate blindness, manufacturing complexity, and not invented here syndrome. Detroit's engineers were locked into their paradigm of transfer cases and manually shifted systems. The idea of using centrifugal governors from windmills would have seemed absurd to them. They were automotive engineers, not farmers. What could farmers possibly teach them about four-wheel drive? Manufacturing was another issue. Dodge was set up to build thousands of identical transfer cases using automated production lines. Marsh's system required custom fabrication, hand fitting, and individual calibration. You couldn't stamp these out in a factory. Each one had to be built specifically for its application. This violated every principle of mass production. There was also the liability concern. Factory systems had been tested, certified, and insured. Marsh's contraption was a collection of farm equipment parts welded together in a barn. If something broke and someone got hurt, who would be responsible? Never mind that the system was actually more reliable than the factory setup. Legal departments don't care about reality, only paperwork. Plus, Dodge was making serious money on four-wheel drive options. The markup on factory systems was enormous. Why would they want to offer something cheaper and better that would cannibalize their profit margin? Better to keep selling expensive, complex systems that required expensive, complex repairs at authorized dealerships. The corporate mindset was the real problem. Dodge had invested millions in transfer case technology. They had patents, production lines, supplier relationships, service procedures. Admitting that a better solution existed would mean admitting all that investment was wasted. It's easier to ignore innovation than to acknowledge you've been doing it wrong. The underground network. But here's the thing about good ideas in rural communities. Word spreads fast. Marsh showed his system to his neighbor. That neighbor showed his cousin. Within 6 months, a dozen ranchers had copied it. Within a year, there were probably 50 Marsh-style conversions running around the Texas Panhandle. The underground network that developed was fascinating. Ranchers would swap notes on governor calibration, share fabrication techniques, help each other source parts. Someone figured out that International Harvester tractor PTOs worked better than the cobbled-together units Marsh had originally used. Another rancher discovered that Chevy front axles were easier to narrow than Dodge units. The design evolved and improved through this informal network faster than any corporate R&D program could have managed. A machine shop in Amarillo started offering conversion kits. They'd sell you the brackets, cables, and modified governor assembly for $500. You still had to source your own front axle and do the installation, but it made the conversion accessible to guys who couldn't fabricate from scratch. The shop did about 200 kits in 1977 and 78, before Dodge's lawyers sent a cease and desist letter claiming patent infringement. Which was hilarious because Dodge had never patented anything remotely like Marsh's system. But the machine shop owner didn't have money for lawyers, so he shut down the kit production. This just drove the conversions further underground. Ranchers started doing them in their own barns. No paper trail, no advertising, just word of mouth. The performance reputation of these conversions became legendary. There were stories of Marsh-converted trucks pulling factory power wagons out of mud holes, of construction crews buying converted trucks because they worked better on job sites, of one conversion running for 200,000 miles with zero maintenance on the four-wheel drive system, except for greasing the governor bearings once a year. The community aspect was beautiful. These weren't competitors hoarding trade secrets. They were neighbors helping neighbors solve common problems. If someone figured out a better way to mount the governor or a more reliable cable routing, they'd share it at the local feed store. This collaborative approach to innovation produced rapid improvements that would have taken Dodge years to develop through formal channels. Detroit's response. Detroit finally caught up in the early 80s, though they'd never admit where the idea came from. The introduction of electronic four-wheel drive systems that engaged automatically based on wheel slip sensors was basically Marsh's concept executed with computers instead of windmill governors. Except the electronic systems cost 3 times as much, required specialized tools to repair, and failed with depressing regularity. Modern automatic four-wheel drive systems owe everything to guys like Clayton Marsh, who proved the concept was viable. Every time you drive a truck with automatic four-wheel drive that engages seamlessly when traction is lost, you're using technology that a Texas rancher figured out using windmill parts in a barn in 1976. The irony is thick. Detroit spent millions developing electronic systems that did exactly what Marsh's mechanical system had done years earlier. They added complexity, cost, and failure points while claiming innovation. Meanwhile, the simple, reliable mechanical solution was being built in barns across Texas for a fraction of the cost. The legacy and what happened. What happened to Marsh's original truck? He drove it until 1994, put over 400,000 miles on it, and the four-wheel drive system never failed once. He replaced the clutch 3 times, went through 2 transmissions, rebuilt the engine twice. The governor-based four-wheel drive kept working. When he finally retired the truck, his grandson pulled the four-wheel drive system and installed it in a newer Dodge. It's still running today. Marsh himself passed away in 2006 at age 68. He never patented his system, never tried to commercialize it, never sought recognition. He built it because he needed it to work, and he shared it because that's what ranchers do. The technical legacy lives on in those few remaining conversions still running in West Texas. Mechanical fossils proving that sometimes the best engineering comes from guys who build what they need rather than what they're told to want. There are still a handful of these conversions operating today. They're museum pieces that happen to be daily drivers. Every one of them has a story, usually involving multiple generations of the same family keeping them running. They're not valuable in a collector's sense, but they're priceless in a practical sense. They represent a moment when innovation came from necessity rather than marketing departments. The broader lesson transcends automotive history. This story is about recognizing when established solutions are inadequate and having the courage to build something better, even when experts say it's impossible. It's about looking at technology from other fields and asking what if. It's about the advantage of necessity over convention. Marsh didn't care what automotive engineers thought was proper. He cared what worked on his ranch. It's also a reminder that innovation doesn't always come from labs and research departments. Sometimes it comes from people who understand their problems intimately because they live with them every day. Marsh knew exactly what he needed because he'd gotten stuck enough times to understand the problem in his bones. The Dodge engineers who designed the Power Wagon's four-wheel drive system probably never spent a day working on a ranch. They were solving theoretical problems. Marsh was solving real ones. The simplicity of Marsh's solution is what makes it beautiful. While Detroit was building increasingly complex transfer cases with more gears, more clutches, more failure points, Marsh went the opposite direction. Fewer parts, simpler mechanism, more reliable operation. This violated everything Detroit believed about progress, which is probably why they never considered it. There's something almost poetic about using windmill technology to solve a four-wheel drive problem. Windmills had been automatically adjusting to changing conditions for over a century. They'd been pumping water through droughts, storms, temperature extremes, and general neglect with minimal maintenance. Of course, that technology could be adapted to four-wheel drive. It just took someone who understood both worlds to make the connection. Today, when electronic systems fail and leave you stranded, When expensive repairs wipe out your bank account, when you need a computer to diagnose your four-wheel drive, remember that it didn't have to be this way. There was a brief moment in the 70s when a better solution existed. A solution built from windmill parts that worked reliably for decades with minimal maintenance. That solution got buried by corporate interests and patent lawyers and the relentless march of electronic complexity. But the idea survives. Somewhere in West Texas, there's still a truck running Marsh's conversion, still engaging automatically when needed, still proving that sometimes the best technology is the simplest technology. And maybe, just maybe, the next innovation in automotive design won't come from Silicon Valley or Detroit. Maybe it'll come from someone's barn, someone who's tired of expensive systems that don't work, someone who looks at old technology and sees new possibilities. Clayton Marsh didn't outsmart Dodge by being smarter than their engineers. He outsmarted them by being willing to think differently, to look outside his field, to build what he needed rather than settling for what was available. That's not just engineering. That's wisdom. And that wisdom is worth more than all the patents and research budgets in the world.